In this video, we're going to take a look at the last type of transformation we're going to see this year. They are dilations. And to start off with, we're going to look at how we define those. So it all has to do with distance to a center. So a dilation is going to take the distance from our pre-image to our center and either shorten or lengthen that distance to get to our image. So this is going to give us a similar figure, and that distance that's relative to both of them, we call that scale factor. So this is going to change the size of our pre-image, but it doesn't change the shape. So that's why we call this thing a similarity transformation. So for example, we may start with the pre-image on the left, triangle ABC, and end up with the image on the right, which looks like it's bigger. And the relative size of those that the dilation produced is going to be what we call the scale factor. So we're going to start with things in the XY plane, or pretty much going to stick with things in the XY plane. So for example, let's suppose I have point A at 3, 4. I could find the distance to the center or the origin using the distance formula or Pythagorean theorem. So if you find the length of that green segment there, you should notice a 3, 4, 5 pattern. The X is 3, the Y is 4. So it seems like that green segment should be 5, and you can double check that. So let's suppose that I'm going to use a dilation with the scale factor of 2. What that would do is it would take point A and it would move it twice as far away from the origin in the same direction. So instead of being 5 away from the origin, I would need to be 10 away from the origin in the same direction. So if you were to extend that green segment, instead of being 5, if you make it 10 units long, which you can make with another 3, 4, 5, maybe 6, 8, 10. That would take you to your image, which would be at 6, 8. And you could actually find the distance from that image to the center and compare it, and you are going to see that it is twice as far. You might be going, whoa, how in the world did he come up with that new set of coordinates? Well, if my scale factor is 2, notice the difference in the coordinate values. So the X was a 3, now it's 6. The Y was 4, and now it's 8. So I could have just like doubled or multiplied by my scale factor to get my image. And in general, that is true. So for any dilation with the scale factor of A, we can always express using coordinates that dilation to take any point x, y and send it to the point ax, comma, ay. So let's say that we have point T that has coordinates 8, -12. And I'm going to use 3 different scale factors to figure out where the image is going to land. So if you want to pause the video, you can do a quick little check and see. But I'm going to go ahead and spoil it. So if I've got a scale factor of 3, I can multiply 8 by 3 and -12 by 3. And then the same is going to go for a quarter and -2. So that means if my scale factor is 3, I should end up at 24, -36. If my scale factor is a quarter or 1/4, I should end up at 2, -3. And if it's -2, negative scale factor, that's going to change the sign of both of them. So -16, +24. You should also notice a pattern. When I have a negative scale factor, we'll see this in class when we start graphing these out. This should look a whole lot like another kind of reflection and another rotation that we've done before. So lastly, let's say we have a triangle. How would this work out with, instead of just one point, a set of points? So if you have a polygon, a segment, whatever the case is, to do a dilation with any scale factor, you just want to go vertex by vertex. So like point A is at 0, 9. If I've got a scale factor of 1/3, I just multiply 0 by a third and 9 by a third, and I should end up at 0, 3. And then for B, if I'm over at 9, 3, kind of the same thing. If I basically divide both of those by 3, I end up at 3, 1. And then if I take C, if I divide the coordinates -6 and +6 by 3, I should get -2 and +2. So connect the dots, and there's my image. So that's the gist of dilations, and we'll do more of this in class.